Students, let us solve this numerical together. A disabled automobile is pulled by means of ropes subjected to forces as shown in figure. Determine the magnitude and direction of their resultant using parallelogram law and triangle law. Here, to consider parallelogram law, we need the forces that are mentioned. So P, let's consider as 4 kilonewton. Q, let's consider as 2 kilonewton, and let's calculate the resultant. So P is equal to 4 kilonewton. Q is given as 2 kilonewton. Here, for parallelogram law, theta is always the angle between the two tail ends of the two forces that are mentioned. Over here, theta will be accumulation of 30 degrees and 25 degrees. Therefore, theta will be equal to 55 degrees. Here, since resultant's magnitude and direction both are unknown, therefore R is unknown as well as alpha is unknown. Let's formulate the equation. According to parallelogram law, R is equal to root of P square plus Q square plus 2PQ cos theta. Let's put the values. So that will be 4 square plus 2 square plus 2 into 4 into 2 cos 55 degrees. All of this under the root. That gives us the value of R as 5.4 kilonewton. Now let's calculate the angle. So alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. By putting the values, we get alpha is equal to tan inverse Q is 2 sin 55 divided by 4 plus 2 cos 55. We get the value of alpha as 17.65 degrees. Now let's solve this by the second method, that is law of triangle. In this, we will first formulate a triangle. Consider the 4 kilonewton force as it is parallel to the existing force. Let's mention this as 4 kilonewton. Secondly, the second force, that is 2 kilonewton, we have to draw that 2 kilonewton parallel to the in the same parallel way. We just have to see to it that since the direction and the magnitude of the resultant is unknown, therefore we should not consider the resultant either horizontal or vertical. Let's consider it in an inclined manner. So we have drawn 4 kilonewton parallel to the 4 kilonewton mentioned. Let's draw the 2 kilonewton parallel to the 2 kilonewton which is mentioned. So we write this as 2 kilonewton. We will draw a resultant which comes out to be slightly inclined. So that is the value of R. This horizontal line over here, let's draw the same horizontal line over here. This horizontal line shows us the angles between P and Q. Similarly, this force P will be inclined at an angle of 30 degree as mentioned in the question, and over here it will be inclined at an angle of 25 degrees. Overall, the angle is 55 degrees, and a complete straight line gives us an angle of 180 degree, which leaves us over here as 180 minus 55 as 125 degrees. Now, according to parallelogram law as well, alpha is always the angle between the first force and the resultant. So considering this as alpha, let us now calculate this angle, which will be 180 minus 125 minus alpha. So this angle comes out to be 55 minus alpha. Let's go ahead and solve the numerical. We'll put this into the equation. So force 4 divided by sine of opposite angle, that is 55 minus alpha, is equal to 2 divided by sine alpha is equal to R divided by sine 125. Let's write it down. So 4 divided by sine 55 minus alpha, that is equal to 2 divided by sine alpha, that is equal to r divided by sine 125. We will first solve these two equations. We will go ahead and use the calculator. Again, clear the memory. After clearing the memory, let us put in the values. So we have the equation as 4 sine alpha x, this alpha and this equal to 2 sine bracket 55 minus alpha x. We close the bracket, shift solve, shift solve. Two minutes, let me just repeat it. So that is 4 sine alpha x, alpha equal to 2 sine bracket 55 minus alpha x, bracket close, shift solve, shift solve. This leaves us with an angle 17.65 degrees, from which we can now, using the remaining two equations, calculate the value of r, which turns out to be 5.4 kilonewton.